In this video, we're going to be talking about polygons, specifically what a polygon is, and how to find the measures of interior and exterior angles. If at any point in this video you feel like I'm going too fast, you need to see something again, just pause the video, back it up, rewind, replay it, whatever you need to do. This video is self-paced. If you need to pause it or go back, please do. So the first thing that we need to talk about is what a polygon is. And a polygon is simply a shape. It's a shape that has at least 3 sides, and it has to have no gaps. It has to be a closed shape. So a triangle is a polygon, a square is a polygon. So it has to have at least 3 sides. Now, one thing that is a shape that we don't think of as a polygon is a circle. Circles don't have any sides, it's just a big curve, so it is not a polygon. But a polygon is a shape with at least 3 sides, and let's say that it is closed. So it is a closed shape with at least 3 sides. A closed shape with at least 3 sides. I'm gonna move this around a little bit. There we go. Okay, so a polygon is a closed shape with at least 3 sides. Now, this term, just a second. Okay, this term diagonal is one of the ways that we use to one of the things we use to describe our polygons. So these red things in our shapes here, are diagonals, and those split up the shape into different triangles. We'll talk about that more in just a second. So a diagonal is a way to split up a shape, and it's just a segment. It's a line segment connecting 2 corners of the shape. Now, the last vocabulary term we want to talk about is what it means for a shape to be regular. Now, there's 2 types of shapes. There's regular and irregular. All of these shapes here are irregular. Irregular. That's with an I. These are irregular shapes. And what a regular shape is something that has all the sides congruent and all of the angles congruent. So a regular shape has all sides and angles congruent. So, for example, a regular shape might be a square. Or an equilateral triangle is a regular shape. But anything that has different sides or different angles is irregular. Okay. So next thing we're going to do, we're going to fill in this table with the number of sides, the number of triangles, and then the sum of the interior angle measures for each type of polygon. We're going to use this table to figure out a general rule for this process. So starting with a triangle, we should know that a triangle has 3 sides. A quadrilateral has 4 sides, 5 sides for a pentagon, 6 sides for a hexagon, and an n-gon is a new term. And all that means is it is a figure with n sides. We use this mostly when we've got a lot of sides, but we can also use it when we just don't know what the shape is called. So an n-gon could have like 42 sides or 13 sides. We're going to call that an n-gon. It's some hypothetical shape. Okay, so if you look here at our pictures, you'll see that a triangle has 1 triangle in it. Okay, pretty straightforward. A quadrilateral, based on my diagonals, has 2 triangles in it. Pentagon has 3, and a hexagon has 4. Now, I want you to pause the video and see if you can figure out what the number of triangles would be in a hypothetical n-sided figure. Okay? You should have gotten that the number of triangles is n minus 2. N minus 2. Because if you look here, the relationship between the number of sides and the number of triangles as we go this way is that the number of sides we have subtracted 2 is the number of triangles. So if we have n sides, there should be n minus 2 triangles. If there's 100 sides in your figure, there are 98 triangles. Okay. Now the sum of the interior angle measures, the last box we're going to fill in on our table. If you know how to fill this in, go ahead and do so. Pause the video and you can check yourself when you're done with that. So the triangles, every triangle has 180 degrees in it. And every quadrilateral has 360 degrees. Pentagons have 540. Hexagons have 720 degrees. And a hypothetical n-gon has a pattern to it. It's not a specific number, but if you notice, each of these is going up by 180 each time. So as we increase the number of triangles, we're going up by 180. So if there's 4 triangles, that's 4 times 180, which is 720. If we have n minus 2 triangles, that's n minus 2 times 180, which will give us the sum of the interior angle measures. So the general rule for how we're going to find the interior angle sum is by doing the following. We're going to first figure out the number of sides. You might need to count it, or it might tell you. So we're just going to find the number of sides. And I'm putting that in this here. Find the number of sides. Subtract 2. Then multiply by 180. And that's how you find the sum of the interior angles of a polygon. So those are the angles on the inside of your shape. And there's this theorem right here. This is the polygon interior angle sum theorem that lines that out. Gives us that definition, n minus 2 times 180. And this says the sum of the interior angle measures of an n-sided convex polygon is this term. Convex is something like this. Convex is something like this shape. That's in contrast to something called concave. Which would be like this. That's a concave shape. So it's kind of like pushed in a little bit. Okay. Next thing we're going to do, we're going to fill in another table. And this is just for your reference. We're going to be filling in the number of, well, we're going to be filling in the names of different polygons based on their sides. This is going to be a good reference for you to use whenever you have a question that says, what is the interior angles of this shape? You got to know what the shape is, how many sides it's got. Okay, so a polygon with 3 sides is a triangle. Sorry, my Apple Pencil's messing up a little bit. I'm trying to get through this. The name of a polygon with 4 sides is a quadrilateral. If you feel like you know these, go ahead and start filling these in. Quadrilateral. 5-sided figure is a pentagon. Something with 6 sides is a hexagon. Seven is a heptagon. An 8-sided figure, everybody should know this one, is an octagon. Something with 9 sides, there's maybe a new one, is a non-agon. 10-sided is a decagon. We're going to skip 11 and 12-sided because they're not super common. And we're just going to go straight to this last one, in-gon. Talked about that earlier. Something with n sides is called an in-gon. So if it has, for instance, (23) sides, this would just be called a 23-gon. So n is not the name, it's just like a placeholder, just like x. Okay, make sure you have this down. If you need to pause it and finish copying that down, go ahead and do so. And then we're going to go ahead and move on to the next page.